Did you just say Happy Easter? I think you did.
Yes, you did.
I did it. I said Mary Chrysler.
Oh, that makes sense too. All right. Okay, so a prime number we will start with is a number with only two factors. And they are 1 and itself. So, if x is prime, then the only factor tree you can draw for it is 1 and x. Okay? It behooves you to know the first few prime numbers. It is useful to you. 2, 3, 5, 7. What's next? 11. What's next? What's next? 17. What's next? 19. No. 23. 20. 29. That's pretty good. If you're good to there, you're pretty good. Please notice there is no pattern. Prime numbers appear to be distributed randomly through the real number system. Okay? They have recently, and I say the word they, that phantom they that does everything in the world. Oh, do you know what they just found out? I'd like to know who the they are, but we never will because they're the shadowy cabal that runs our universe. They have recently discovered the largest prime number, and it is something crazy large. The largest prime number of which we know. It's like up in the billions, which is nuts to me that a number that far up can only have two factors. Preston.
If you find new prime numbers that are super high, you sell them for money.
Yes, that's what I was just about to say. Finding new prime numbers is actually business. Because prime numbers are very important in doing math. Okay. I don't know, Jasleen, because my knowledge of prime numbers ends very low on the scale. I have stopped caring past about 29. After about 29, I'm like, wow, that's prime? That's surprising to me. All right. So now we are going to go back to grade 5. We are all sitting in our 1985 DeLorean with its flux capacitor and its plutonium tank is filled. We are going to go back to the 5th grade and we are going to draw a factor tree for the number 54. I am betting that if I ask you to draw a factor tree, that all 30 of you, your first two branches are going to be 9 and 6. That is my bet. Am I right? Then what are you going to do? You're going to go 3 and 3. And then you're going to go 2 and 3. Wait a minute. You're going to go 3 and 2. And anytime a branch hits a prime number, you're going to do what, Toya? You're going to circle it. That is most likely how almost all of you were taught to factor tree. There are other ways. I do not care. Use the way you want. Here is one of the ways I was shown. 54. And we were taught to start with the smallest prime number. So since that's even, it's going to end in what? 2. Or it's going to divide by 2 because it ends in 4. So we were taught to go 2, then 27, then 3, then 9, then 3, then 3. 2 goes into 54 27 times. 3 goes into 27 9 times. 3 goes into 9 3 times. I'm not saying it's right or wrong. I'm just saying this is one of the ways I was taught to factor. Okay? Again, I don't care what you use. Do any of you have a third or different way that you were shown? My daughter was taught some weird thing with Venn diagrams. like Venn diagrams, these things. Yeah, I don't dig those either. I don't even understand it. And I'm a math teacher. I was looking at her work and I'm like, I got nothing, Beth. She's like, well, I think it means this. And I look at it. I think it might mean that too. Go ahead and do that. And then when you're in grade 9, you can forget that. And then when you're in grade 10, you can forget that. Because in grade 10 and 11, they'll show you a good way that works all the time. And that's the way you should use. But whatever. Everybody's cool with that, yeah? Everybody can factor, right? Okay. Now the next step that you may or may not have done in the 5th grade is you should list your factors. Now, I like to list them using exponents, but I have found in my 20 years of teaching that the next step, if I write it out with just exponents, confuses you people. So I'm going to write it out both ways. 2 times 3 times 3 times 3, or 2 times 3 cubed. Everybody cool? All right. Now, do the same thing with 162. I am betting most of you with 162, because it's a big number that ends in 2, you're going to go 2 and 81. That's my guess. Then, you're going to circle the 2. You're going to go 9 and 9, 3, 3, 3, 3. And you're going to get 2 times 3 times 3 times 3 times 3, or 2 times 3 to the 4th. That's my guess. Everybody cool? Ease, bees, lemon squeezy, yeah? What's the only thing that makes this difficult? Division, right? But you were taught a bunch of little division shortcuts back in the day, and if you know them, they will be helpful to you. I know of a few. Obviously, if the number ends in 0, 2, 4, 6, or 8, you can divide it by 2. Who knows the one for 3? If you add the digits and they add up to a number that divides by 3, then that number divides by 3. So 1 plus 6 plus 2 is 9. 9 divides by 3, so 162 will divide by 3. Does anybody know? There's one for 4, but I can't remember what it is. It has something to do with 2. I don't remember what it is, so I don't care. What's the one for 5? If it ends in 0 or 5, it divides by 5. What? Yeah. I don't write them down because I hate learning things like this. I think it's a waste of your brain power. What is the one for 6? If it's divisible by 2 and 3, it divides by 6. And the next one, of which I know, is 9. And I can't remember what it is. It has something to do with the numbers adding up to a multiple of 20. I don't care. I don't know. I really don't. So if you have those divisibility rules in your head, use them. Or know your times tables and know how to divide. I know which one serves me in better stead, knowing how to divide, because it always works. Then I'm not fishing through my brain for whatever shortcut is trapped in there. Okay? But you do you. Aight? Now, got a bunch of new terms here. Not new at all. You know what they all are. A greatest common factor, which I'm going to underline in red. Whenever I do the greatest common factor, I will be using red ink. You know what those words mean. What does greatest mean in English? Largest. In math, what does that mean? The left or the right? The right. The further you go right, the greater the number is. Yes? Okay, so you know what greatest means. What does common mean in English? Shared, right? We are all share in common that we are in this room right now. Right? Great. And what are factors? We just found a bunch of factors, didn't we? They're the numbers that multiply together to make a product. So the greatest common factor must be what? Close. Close. A greatest common factor is the greatest shared factor between two numbers. Now, you guys are intelligent people. There's your list of factors, yes? What's the greatest common factor? Some of you are going to say 3, yes? Because they're both only 2s and 3s, right? But you will notice something about that. There is not just 1 3 common, is there? There are 3 3s common and a 2, right? Now, isn't 2 times 3 times 3 times 3 all factors of a bigger number? So, how do we use the prime factorization to find the GCF? GCF can be found using prime factorization by multiplying all of the common factors. And I'm going to highlight common in yellow. Okay? Now, you have all done greatest common factor before. You mostly do it in your head, and we don't call it greatest common factor. Don't write this down. Is that a fraction? Is that a fraction you would ever hand in? Why not? You can simplify it. What would you simplify it to? 1 over 5. Why? What did you do to get from there to there? You divided by 4. And what did you do there? You divided by 4. Because 5 times 4 is 20, and 1 times 4 is 4, which means 4 is a greatest common factor of 4 and 20. Okay? You're all able to GCF all the time. Every time you've ever simplified a fraction, you are applying these principles. Okay? But that's about the only time you've done it. We're going to give you today, over the course of the next couple of days, I'm going to give you another time when GCF comes into play. Okay? Next, in blue, because I will always do my lowest common multiples in blue. Lowest common multiple is slightly more difficult to explain. If a factor is the building blocks towards a product, then what is a multiple? Factors are on the left side of the equal sign, the way we usually write them. Where are the multiples? On the right. 2 times 3 are factors. 2 times 3 equals 6. 6 is a multiple. Because you got there by multiplying smaller numbers. Everybody cool? Factors are the smallest. Multiples are the biggest. Okay? Everybody with me? All right. So a lowest common multiple is the smallest number which has all of your group as a factor. Okay? So, 2 times 3, those are factors. I forgot the C. Those are factors. Equals 6. 6 is a multiple. So the lowest common multiple of 2 and 3 is 6. Because 6 has both 2 and 3 as a factor. Everybody cool? Now again, don't write this down. This is something that you already know how to do. 3/5 plus 2/4. I don't want 3/4. How do you add those? What do you have to do? Find the lowest common denominator, which is, of course, 20. Right? You already know how to find the lowest common multiple. And you've been doing it since the 4th grade, but your teacher called it lowest common denominator. Okay? but it is indeed just the lowest common multiple. How do you find the lowest common multiple? It's similar. We need to use prime factors, but by multiplying not just the common ones, multiplying every prime factor, but only once. And here is what I mean. We're going to put it into practice right now. I had 2 times 3 times 3 times 3. Yes? That was 54's factors. Yes? And 162 was 2 times 3 times 3 times 3 times 3. Right? GCF is only the common factors. Is there a 2 common? Yes, 2. Is there a 3 common? Yes. Is there another 3 common? Yes. Is there another 3 common? Yes. So that is your GCF, which equals 54. Now people always say, how can 54 be a factor of 54? What's 1 times 54? So 54 is a factor of 54. Everybody cool? Now, I said that I also do this. I like to use exponents. So I'm going to change shades of red slightly and move to hot pink. 2 times 3 cubed, 2 times 3 to the 4th. Now observe. 2 is still common, and that guy has 3 3s to give, 3 cubed. This guy has 4 3s to give. So there's 3 3s that are common to both. And that will still equal 54. Everybody cool? You're going to get lots of practice on it, doesn't matter. As long as you understand that we are counting everything that is common. Yeah? All right. Now, let us move on to lowest common multiple. Again, 54 is 2 times 3 times 3 times 3. 162 is 2 times 3 times 3 times 3 times 3. And I want everything once with no repeats. Okay? So, is there a 2 counted? Yeah, because it's in both. Do I count it twice? How many times do I count it? Once. 2. Is there a 3 in both? How many times do I count it? Once. Is there another 3? How many times do I count it? Is there a third 3? How many times do I count it? Must I count the last 3? Yes, because I count every prime factor, but only once. So do I count this guy? Yes. 2 times 3 times 3 times 3 is 162. How can 162 be a multiple of 162? What's 1 times 162? 162. So 162 is a multiple of 162. And 3 times 54 is 162. Everybody good? Now, of course, again, I like to use exponents here, so I'm going to change shades of blue and show you this with exponents. 2 times 3 cubed, 2 times 3 to the 4th. Count everything once. 2, they're both there, so I count it. How many 3s must I count to cover everybody? This guy has 4 3s. Does that 4 3s account for these 3 3s? Yes. 3 to the 4th, which is 162. Does everybody understand? I'm going to get you to practice this 4 times on the next page. This is all we are doing today because I want you proficient at it. Turn the page over. I'm going to make one small change. At the bottom here, I'm going to add the number 18. So you are going to do 35, 84, and 18. I don't want to do 18. Hold up. I want to do 112. Yeah. Okay? Remember, this is not a test. You are welcome to do work together. Just remember what you have to do. 1, factor. How you see fit. 2, list factors. How you see fit. 3, apply GCF or LCM principle. If you finish A and you feel you have done a good job, continue. In about 30 seconds, I'm going to do A, and you can check your work. Is everybody good to there? Everybody good? Okay, so now you're going to take what you knew from the 5th grade and you're going to apply our new knowledge. For greatest common factor, I count only common stuff. What's common? How many 2's are common to both of them? 2 2's. How many 3's are common to both of them? 1 3. How many 5's are common to both of them? None. So it is 2 squared times 3, which is what? 12. Now I check. Does 12 go into 36? Yeah, 12 times 3 is 36. Does 12 go into 120? Yeah, 12 times 10 is 120. So I'm good. Then I do lowest common multiple, which means I count what? Everything how many times? Once. How many 2's do I need to count to account for everybody? 2 cubed. How many 3's do I need to do to account for everybody? 3 squared. How many 5's do I need to do to account for everybody? 5 to the 1. 2 cubed is 8. 3 squared is 9. 8 times 9 is 72. 72 times 5 is 360. Preston.
For 36, would it be 2 squared times 3 cubed?
No, because you only count the common ones. That's why I drew it out in long form on the last page. This guy can only give 1 3 to this list. This guy can give 2 3's as a factor. I'm looking for the greatest common factor, so only one of those 3's is common. Remember, factors must be equal to or less than the smallest number in your group. multiples must be greater than or equal to the largest number in your group. Because factors are the building blocks of multiples. Everybody cool? All right. Let's do the next one. 18. I am betting most of you for 18 are going to go 3 and 6, even though 9 and 2 would work. What is the largest amount of 2s I can get out of everybody? 1, 2. What is the largest amount of 3s I can get out of everybody? This guy only has 1 3 to give. So what's the largest amount of 3s I can get from everyone? 1 3. What is 2 times 3? 6. So we're done. What is the largest amount of 2s I need to count to cover everybody? 2 cubed. What is the largest amount of 3s I need to count to cover everybody? 3 squared, which is 8 times 9, which is 72. Is everybody good? Great, do the next one. Who's telling me what to write in the first one? Thomas? Right. I would write 3 times 5. Keep the smallest one first, but that's just me. 3 times 5. Thomas, why did you only use 1 3? I can see here there's plainly 2 3s there. I'm looking for factors, right? This guy has 2 factors. This guy only has 1. So I can only take out 1. Excellent. And the same thing here. What is the LCM? 3 squared times 5 squared, which is 9 times 25, which is 225. Because I got to count everything once, right? The first 3 this guy has covers his 3. But that leaves me with, I still got to count the second 3. This guy's 5 covers one of this guy's 5s, but I got to count both of them. Everybody good? What is different in D? There's 3. So I must need how many factor trees? 3, which means I have 3 lists of factors. Does anything change? No. I still look for what is common to all 3. And when I'm doing LCM, I count everything once. 35 is a real easy one. 5 and 7. 84 is a little more difficult. 2 and 42 is where I bet most of you went first. That's cool. 2. 42 is 6 and 7. There's another prime. 2 and 3. I shouldn't have circled 6 and 6 because it's not prime. And then 112, 2 and 56, 7 and 8, 2 and 4, 2 and 2. Oops. What is common to all 3? Only 7. Count everything once. What are the numbers that I have to count? Some kids like to do this way. I'm going to do this slightly differently. I have to count everything, yes? So I have to count 2, 3, 5, and 7, don't I? How many 2s must I count? 4. How many 3s must I count? 1. How many 5s? 1. How many 7s? This is where people screw it up. How many 7s? 1. No repeats. 1 7 covers everybody, just like 1 5 covered him. So, what is that answer? 2 to the 4th is 16. 16 times 3 is 48. 48 times 5 is 240. Times 7 is 1400, 1680, is it not? You can check that with your calculator. I think it's 1680. I have an answer. No, because 35 has no 2s. That's okay. That's why we do this. Preston. No, that's a 9. But my pen has started to skip. You will notice as I write. See? There's gaps. I don't know why. Well, I do know why. It's a Microsoft product. Jasleen. Yes. There's 3 2s for 120 and 2 2s for 36. So I have to count 3 2s to cover everybody. There's 2 3s and 1 3. So I got to count 2 3s to cover everybody. And then there's 1 5. So I got to count it because you count everything once with no repeats. Now listen, please, ladies and gentlemen. This is going to get a little weird. On your next page, which is page 119, the left side is what we just did. That's your work. The right side is for later. Okay? So just do the left side now. Aight. Gunika, due to Due to me trying to spell your last name with my body, I killed a pair of Converse before they were ready to go. I'm sad about this. It's not your fault. It's my fault for thinking I'm 43 and I could make my body twist into a J. But it's okay because I had backup pairs. I got a new pair going today. So you needn't feel bad. Not that you felt bad before. No, I am not wearing my Turkish ones. I'm wearing a new pair. No, I am not wearing my knockoffs. But I am wearing a new pair. My wife found them buried in the garage. I didn't even know I had these. I was expecting my next pair to have to be blue. But my wife went down to the garage and she found me these ones, which are purple. Of course, purple being my favorite color. Purple.
Oh, okay. Underneath the jet screen looks black.
Yes, I have actually, ironically, never owned a black pair because that is boring.
I have a pair of not really Converse that maybe sort of looks like it, that are like space colored.
That's because these shoes are made in a factory in China, and they make about 20 million pairs a day. About 1 million pairs a day get that sticker and that sticker. All the rest of them that come off the same conveyor belt don't get that and don't get that. But they're the exact same shoe.
What I meant by that is that it had like a sort of Converse look, but they're like definitely not.
I know. I understand what you're saying.
Yeah.